Hi children, welcome back to the class. Today we shall continue the problems. The children, here we have show that the vectors 2i minus j plus k, comma I minus 3j minus 5k and 3i minus 4j minus 4k forms the vertices of a right angle triangle. To show that, we have by using Pythagoras theorem, we have sum of squares of two sides of a triangle is equal to square of other side. Here just prove that sum of squares of two sides of a triangle is equal to square of other side. Then we can say that this triangle is a right angle triangle which has any one angle as 90 degree. Here given that, so a bar is equals to, we have 2i minus j plus k. Similarly, we have b bar. Vector b is equals to I minus 3j minus 5k and c bar is equals to, we have 3i minus 4j minus 4k minus 4k. Here we have to find the length of this. So we know how to find length, that is magnitude of a given vector. Here therefore magnitude of a bar is equal to square root of, we have formula x square plus y square plus z square. Okay, here what is the value of x? That is 2. 2 square we have 4. Again, what is the value of y? Minus 1. What is minus 1 whole square? We have 1 plus 1 whole square, again we have 1. Therefore that is equal to square root of 6. Root 6. Again we need to find magnitude of vector b. Therefore that is magnitude of b bar is equal to the square root of, we have 1 square 1 plus minus 3 whole square, we have 1 plus 9, again plus minus 5 whole square, we have plus 25, again that is equals to root, so 9 plus 1 10 plus 25, that is 35, root 35. Again next magnitude of c bar, magnitude of c bar, again that is equal to square root of 3 square, we have 9 plus minus 4 whole square, we have 16 plus minus 4 whole square, we have 16, again that is equal to, we have 16 plus 9, we have root 41. Observe here, sum of squares of this is equal to this. Okay, therefore so that is magnitude of c bar whole square is equals to magnitude of a bar whole square plus magnitude of b bar whole square. Okay, so that is, here what is the value of this? We have root 41. Root 41 whole square is equals to, we have root 6 whole square plus root 35 whole square, root 35 whole square. Again that is equal to 41 is equal to 35 plus, sorry, we have 6 plus 35, 6 plus 35. Again that is equals to, that implies 41 is equals to 41. So therefore a bar, b bar, c bar forms the vertices of a right angle triangle. Next we have show that the points with position vectors I plus 2j plus 3k, comma 2i plus 3j plus k and 3i plus j plus 2k forms the equilateral triangle. So what is equilateral triangle? Any triangle is said to be equilateral triangle if all the sides of a triangle are same. That is, if the length of this side is 5, then this must be what? 5, and this must be what? 5 units. Then such a triangle is called as what? Equilateral triangle. Okay, as given A, B, C. Now we have to find A, B, B, C, C, A. Show that if A, B is equal to, that means the length of A, B is equal to length of B, C is equal to length of C A. Here we have to find what? Magnitude of AB bar, magnitude of BC bar, magnitude of CA bar. If all the magnitudes are same, then we say that the triangle is equilateral triangle. Here given that the position vectors, therefore as given OA bar. So OA bar is equals to, we have I plus 2j plus 3k. Again we have OB bar is equals to 2i plus 3j plus k, and OC bar is equals to, we have 3i plus j plus 2k. Here I have told that we have to find what AB bar, BC bar and C bar. We will find AB bar. So that is AB bar is equal to, we have to write this in terms of its position vectors. So it can be written as that is OB bar minus OA bar. Okay. So again that is equal to OB bar minus OA bar. This minus this. We have subtraction of components of two vectors. That is, we have 2 minus 1. We have that is 1i. Again 3 minus 2. We have plus. We have 1j. That is simply j. Again we have so 1 minus 3. We have minus 2k. Minus 2k. So we will find magnitude of this. That is, therefore again magnitude of AB bar is equal to square root of, so 1 square 1 plus 1 square 1 plus minus 2 whole square. We have that is plus 4. Again that is equal to root 1 plus 1 plus 4 plus 1 plus 1. We have root 6. Okay. Similarly find BC bar. So again that is BC bar is equal to OC bar minus OB bar. OB bar. So this minus this, we have 3 minus 2. We have I. Again 1 minus 3. We have minus 2j. Again 2 minus 1. We have 1k. 1k. Similar find what? Magnitude of BC bar. Magnitude of BC bar is equal to square root of, we know how to find a magnitude of any vector. So here 1 square 1 plus minus 2 whole square. We have plus 4. Again so we have plus 1. This is okay. So again 1 plus whole square. We have what? 1. That is equal to root 6. Root 6. Again we need to find what? CA bar. Therefore CA bar is equal to OA bar minus OC bar. OC bar. Again that is equal to this minus this. OA bar minus this. Okay. We have 1 minus 3. That is minus 2i. Again 2 minus 1. We have 1j plus 1j. Again we have 3 minus so sorry 3 minus 2. We have again plus 1k plus k. Again find CA bar. Magnitude of CA bar. Again that is equal to square root of minus 2 whole square. We have plus 4 plus 1 whole square 1 plus 1 whole square 1. Again that is equal to root 6. Root 6. Now compare AB bar, BC bar, CA bar. We have same value, that is root 6. That is therefore magnitude of AB bar is equals to magnitude of BC bar is equals to magnitude of CA bar. CA bar. Therefore the points with position vectors forms the equilateral triangle. Okay. I already told that if magnitude of the length of this is equal to length of this is equal to length of this, then we say that this triangle is what? Equilateral triangle. Therefore we have magnitude of AB bar is equal to magnitude of BC bar is equal to magnitude of CA bar, that is equal to root 6. Therefore it forms a equilateral triangle. Next, show that the points with position vectors I plus 2j plus 3k comma minus I minus j plus 8k and 4 minus 4i plus 4j plus 6k forms equilateral triangle. Same question with different position vectors. Here we have OA bar. So OA bar is equals to, we have I plus 2j plus 3k. Again we have OB bar. OB bar is equals to minus I minus j plus 8k and OC bar is equals to, we have minus 4i plus 4j plus 6k. So we need to find AB bar, BC bar, CA bar and their magnitudes. If their magnitude is same, then we say that this position vectors forms a equilateral triangle. So we'll find first AB bar. So AB bar can be written as OB bar minus OA bar. Okay, again that is equal to this minus this. Here minus 1 minus 1, we have minus 2i. Again minus 1, here minus of plus, we have minus 1 plus 2, we have minus 3j, minus 3j. Okay, here we have 8 minus 3, we have plus 5k. Again, so find the magnitude of AB bar. Therefore magnitude of AB bar is equal to square root of minus 2 whole square, we have plus 4, plus minus 3 whole square, we have plus 9, plus 5 whole square, we have 25. Again that is equal to root 38. Similarly, we need to find BC bar. Therefore BC bar is equals to OC bar minus OB bar. Again that is equals to, we have OC bar, this minus this. So minus 4 minus of minus 1, we have plus 1. Therefore minus 4 plus 1, we have minus 3i. Again 4 minus of minus plus, that is plus 5j. Again 6 minus 8, we have minus 2k. Similarly, we need to find magnitude of BC bar, that is equal to square root of minus 3 whole square, 9, plus 5 whole square, we have 25, plus minus 2 whole square, we have 4. Again that is equal to, we have root 38. Next we have to find CA bar. So CA bar is equal to OA bar minus OC bar. Again that is equal to, so this minus this, OA bar minus OC bar. So 1 minus of minus 4, we have that is 5i. Again this minus this, 2 minus 4, we have minus 2j. Again we have this minus this, that is 3 minus 6, we have minus 3k. Again therefore magnitude of CA bar is equal to square root of 5 whole square, we have 25, plus minus 2 whole square, we have 4, plus minus 3 whole square, we have 9. Again that is equal to 25 plus 4 plus 9, we have root 38. So now compare magnitude of AB bar, BC bar, CA bar. We have root 38. So therefore that is magnitude of AB bar is equals to magnitude of BC bar is equal to magnitude of CA bar. Okay, therefore the position vectors this and this forms a equilateral triangle. Next we have show that the vectors 2i plus 3j plus 4k and minus 4i minus 6j minus 8k are collinear. We know that any two vectors are said to be collinear if and only if we have two conditions. One vector is equal to some scalar times other vector, or second one, the corresponding scalar components are proportional to each other. Corresponding scalar components are proportional to each other. Use any one condition. Okay, I'll just write. So that is vector A bar is equals to 2i plus 3j plus 4k and B bar is equal to minus 4i, again minus 6j minus 8k. Now A bar and B bar are collinear if and only if their corresponding components are proportional to each other. Corresponding components are each other. So already given if A bar is equals to x1i plus y1j plus z1k and B bar is equal to x2i plus y2j plus z2k, then these two vectors are said to be collinear or parallel if and only if their corresponding components, that is x1 by x2 is equal to y1 by y2 is equals to z1 by z2. Okay, therefore here what are the corresponding components? That is we have that implies 2 divided by minus 4 is equal to 3 divided by minus 6 is equals to 4 divided by minus 8. Here we have 2 by 4, that implies 2 ones are 2 fours are 1 minus 1 divided by 2, again that is equals to 3 ones are 3 twos are minus 1 divided by 2, that is equals to 4 ones are 4 twos are minus 1 divided by 2. Therefore the corresponding corresponding scalar components are proportional to each other. Okay, therefore A bar and B bar are collinear. Therefore vector A and B bar are collinear. Just remember this condition. Next, show that the points A of 1, 2, 7, B of 2, 6, 3 and C of 3, 10, minus 1 are collinear. Here he has given 3 points, so we have to convert them into what? 2 vectors. So therefore given OA bar is equals to 1, 2, 7, OB bar is equals to, so we have 2, 6, 3 and OC bar is equals to, we have 3, 10, minus 1. Okay, we have position vectors are points are same. Okay. Next, so here we need to find AB bar. So AB bar is equals to, we have OB bar minus OA bar, that is this minus this. So I already told you that these points can be written in terms of vectors or vectors can be written in terms of points. So here we have 2 minus 1, again that is 2 minus 1, we have 1, again we have 6 minus 2, we have 4, again we have 3 minus 7, minus 4. Similarly find BC bar. So again that is equal to OC bar minus OB bar. Okay. So this minus this. So here 3 minus 2. We have 1, we have 10 minus 6, we have 4, so minus 1, we have minus 3, we have minus 4. So now comparing or equating the corresponding scalar components. See that again we have that is 1 by 1 is equals to 4 by 4 is equals to minus 4 by minus 4, again that is equals to 1 is equals to 4 by 4 we have 1 is equals to minus 4 divided by minus 4 we have 1. Therefore these points A, B and C are collinear. Okay. Next, similar question, we have show that the points A of vector, B of vector and C of vector are collinear. See here he has given OA bar. So OA bar is equals to, we have minus 2i plus 3j plus 5k. Again OB bar is equals to, we have I plus 2j plus 3k and OC bar is equals to, we have 7i minus k, 7i minus k. So we have to find AB bar and BC bar. Therefore AB bar is equals to OB bar minus OA bar. Okay, again that is equals to this minus this 1 minus of minus plus 1 plus 2 we have 3i again we have so this 2 minus 1 we have minus j again we have 3 minus 2 we have minus 2k minus 2k. So again find BC bar. So BC bar is equals to OC bar minus OB bar again that is equal to OC bar this minus this. Here we have 7 minus 1 we have 6 that is 6 high again we have so here there is no j term, therefore 0 minus 2 we have minus 2j again we have minus 1k minus 3 we have minus 4k. So we know that any two vectors are said to be collinear if and only if their corresponding scalar components are proportional to each other. That is we have that implies 3 by 6 is equals to we have minus 1 divided by 2 is equals to we have minus 2 divided by minus 4 sorry minus again that is equals to we have 3 1s are 3 2s are that is 1 by 2 is equal to we have plus plus cancel we have 1 by 2 again that is equals to my plus plus cancels then we have 2 by 4 that is equals to 1 by 2. Therefore their corresponding scalar components are proportional to each other. Therefore the points that is a comma b and c are collinear Next, if the vectors 2i plus 3j minus 6k and 4i minus mj minus 12k are parallel, find the value of m. We need to find the value of m. So we already know that two vectors are said to be collinear or parallel if one vector is equals to some scalar times other vector, or if their corresponding scalar components are proportional to each other. Okay, here so given a bar is equals to 2i plus 3j minus 6k. Again vector b is equals to we have 4i minus mj again minus 12k. So given that these two vectors are parallel, then their corresponding scalar component must be what? Proportional to each other. Therefore so that is 2 by 4 is equal to 3 divided by minus m is equals to minus 6 divided by minus 12. Simplifying this, 2 ones are 2's are, that is 1 by 2 is equals to, write this as it is, 3 divided by minus m, again that is equal to minus get cancelled, 6 ones are 6 2's are, that is 1 divided by 2. Now equating this with either this or this. Okay, therefore that is 3 by minus m is equal to 1 by 2. Go for cross multiplication, that is 3 into 6 we have 3 into 2 we have 6 is equal to minus m into 1 minus m. Therefore what is m? M is equals to minus 6. M is equals to minus 6. See that he has given these two vectors are parallel, then their corresponding scalar component must be what? Proportional to each other. Okay, therefore that is 2 by 4 is equal to m, 3 by minus m is equal to minus 6 divided by minus 12. Simplify this, we will get m is equals to 6. Next, find the value of x for which x of I plus j plus k is a unit vector. We know the definition of a vector. Unit vector, a vector whose magnitude is unity. That means the magnitude of any vector is equal to 1. Then we say that the vector A is a unit vector. He has given this vector is unit vector. Therefore apply magnitude. Okay. Therefore that is magnitude of, just multiply x into each component, that is x into 1 we have xi plus x into 1 we have xj again plus x into k, that is equal to we have 1, because as given that this vector is a unit vector. We know how to find a magnitude of this vector, that is the square root of here x value x itself only plus y value, that is x itself only plus z value we have x itself only, that is x square is equals to 1. Again square root of x square plus x square plus x square we have 3 x square is equals to 1. Therefore root 3 into x, okay, that is equals to 1. Therefore x is equal to plus or minus 1 divided by root 3, 1 divided by root 3. The children, remember that the given vector is a unit vector, so that means the magnitude of this vector must be equal to what? 1. So therefore magnitude of xi plus xj plus xk is equal to 1. So we know that how to find a magnitude of a vector, that is square root of x square, that is x square plus here y, what is y value? We have x itself only, that is x square plus z value, that is x itself only, therefore x square is equal to 1. Therefore 3x root square root of 3x square is equal to 1, root 3 into x is equal to 1. We know that root square root of x square, here 2 and square root get cancelled, therefore x is equal to plus or minus 1 divided by root 3. Show that the vector I plus j plus k is equally inclined to the axis ox, y and oz. That means x axis, y axis, z axis. So this is a vector, given vector. We have to show that the angle between this and to this and this must be same. So we have to show that this vector makes an equal angle with coordinate axis, that is ox, oy and oz. Children, remember we have to show that equal inclined means we should show that this vector is having the same angle. So that is here we must prove that that is alpha is equals to beta is equals to gamma, alpha is equals to beta is equal to gamma. Okay, then we will say that the angle made by this vector is same with x axis, y axis and z axis. Here therefore given that a bar is equals to I plus j plus k, just find the alpha, beta, gamma, or we say that find L comma m comma n. What are that? They are direction cosines. Okay, here we have magnitude of a bar is equals to square root of 1 square 1 plus 1 square 1 plus 1 square 1, that is equal to root 3. We have L is equals to x divided by magnitude of a bar, again that is equals to 1 divided by root 3. Similarly we have m is equals to y divided by magnitude of a bar, that is equals to 1 divided by root 3. Again n is equals to we have 1 divided by root 3 and 1 divided by root 3, right? So what is L, m, n? Direction cosines. We know that they can be written as what? Cos alpha. Again that is equal to, we have what is the value of here? That is cos root 1 by root 3. Again we have cos beta is equals to, that is cos of root 1 divided by root 3. Again we have cos gamma is equals to cos 1 divided by root 3. Therefore we have alpha is equals to 1 by root 3, beta is equal to 1 by root 3 and gamma is equals to 1 by root 3. Therefore alpha is equals to beta is equals to gamma. Therefore the vector I plus j plus k is equally inclined to the coordinate axis. Okay, so very simple, we need to find the angle made by this vector is same with x-axis, y-axis and z-axis. Therefore, we have alpha is equal to beta is equal to gamma. Therefore, this vector is equally inclined to coordinate axis. Next, we have if AB bar is equal to 2i minus j plus k and OB bar is equal to 3i minus 4j plus 4k, find the position vector of OA bar. We need to find what? OA bar. So, given that AB bar is equals to 2i minus j plus k, and again he has given that OB bar is equals to 3i minus 4j plus 4k. So, we need to find what? OA bar. We need to find what? OA bar. Okay. So, now express this AB bar in terms of its position vectors. Therefore, that is AB bar is equals to OB bar minus OA bar. Okay. So, we have AB bar and OB bar. We need to find what? OA bar. Therefore, bring this OA bar to LHS. That is equals to, again bring this to RHS. Therefore, OB bar minus OA bar, sorry, AB bar. Okay, again that is equals to, we have OB bar, this minus this. So, we have 3 minus 2, that is I, again minus 4, here we have minus 1, minus up minus becomes plus, we have minus 3, minus 3j, again 4 minus 1, we have plus 3k. So, this is OA bar. By using expressing the AB bar in terms of its position vectors. Next, write the direction cosines of number 1 x-axis, y-axis and z-axis. Here we have the direction cosines of x-axis are 1, 0, 0. Again, similarly, the direction cosines of y-axis are, we have 0, 1, 0. Again, the direction cosines of z-axis are, that is 0, 0, 1. So, direction cosines of x-axis 1, 0, 0. Direction cosines of y-axis we have 0, 1, 0. And direction cosines of z-axis we have 0, 0, 1. Okay. Dear children, we will see the dot product of two vectors in the next class. Thank you very much.